So now that we've seen that a computer only has a finite amount of memory and it can only represent numbers finitely, let's actually do an example that will be easy to understand in the terminology we all are familiar with. It won't be exactly how the computer does it. We'll pick that up after we work through this example. So what I've got here is what I'm calling an example of a finite number system. So let's work in 3 digits, base 10, along with exponential notation. What I mean by that is we're going to use 4 symbols to represent our numbers: A, B, C, and E. A, B, and C will represent the 3 significant digits, and their values will be between 0 and 9. There's one exception, which we'll outline below. Then we'll have 1 digit for the exponent, which will also be between 0 and 9. Now, the definition of the number that's represented by these 4 symbols is going to be very simple. So I'll use the notation for now. N, the number represented by A, B, C, and E, is simply the base 10 representation that you've used all along. A, decimal point, B, C, so those are the digits, times 10 raised to the E minus 4. So we'll subtract 4 from E, and we'll see why we're doing that in a moment. So for example, if I write N 7356, what I mean is 7.35, mapping the A, B, C directly above, times 10 raised to the, and then we'll take 6 minus 4, which is really the second power. So I get the number 735. So what we're representing is really numbers with 3 digits of accuracy in base 10. Now, the range of possible numbers is limited. Remember, we only have 3 digits, and we only have an exponent that varies between 0 and 9. Because of the minus 4 offset, the exponent in the end only varies between -4 and +5. So the smallest number we can represent, other than 0, is 0.01. A is 0, B is 0, C is 1, and then E is 0, and that gives us 10 to the minus 4. So we get that number, 1 times 10 to the minus 6. That's the smallest non-zero number we can represent. The largest number we can represent is making A, B, and C all 9, and making E its maximum value, which is also 9. And when you subtract off the 4, you get 10 to the 5th, and that gives us 999,000. Now, if you notice, those 2 numbers are just about reciprocals of one another, if you check. And that's why we did the subtraction of E minus 4. It means that the small numbers relative to 1 and the big numbers relative to 1, that range in a multiplicative sense is about the same. Now, there also are only a finite set of numbers that are represented. If you think about it, we've only got 10 possibilities for the number A, 10 possibilities for the number B, 10 possibilities for the number C, and 10 possibilities for the number E. So there's only, it would take me a long time to write down all the combinations, but there are only a finite number of combinations, right? 10,000. So that's all the numbers we can represent. Now, there's one exception, as I mentioned, and let's see what that exception is. So this is a rule. It's going to make this representation unique, meaning that if I give you a number that is representable, if we follow one additional rule, there's only going to be one way to write that number with the A, B, C, and E. And the rule is that the combination A equal to 0 and E not equal to 0 is not allowed. If you had a number like that, you simply should shift the B digit to the A digit, the C digit to the B digit, 0 to the C digit, and subtract 1 from E. That looks like a mouthful. Let's see what we actually mean. So if I had 0.97 times 10 to the negative 2, I can just write that as 9.70 times 10 to the negative 3. Notice I've shifted everything over 1 digit and then subtracted 1 from the exponent. If I had 0.04 times 10 to the something that I can't see, 10 to the third, I can shift that over, apply the rule once. I still have A equal to 0 because now it's 0.40. So what I'll do is I'll shift it over one more time, and I finally end up with A not equal to 0 when E is not equal to 0. So A equals 0, E not equal to 0 is not allowed. We'll see the implication of that, I think, on the next slide. We have a little quiz.